Hi everyone. Today I will go through my code base for the project. The everything in code of this project is under the code folder right here, as you can see. And there's two subfolder: data and model. The data subfolder contain the files which act as like a makeshift database for our like APIs. You have finance data for the finance API and Google Trend for the Google API. In the Google API, we use the PyTrend request, which is an API built by Google Cloud Service. And we are looking for the keyword Bitcoin for trending indexing on Google search. So the first function is get data, and it try to look up the data, historical data we already pulled previously, and it doesn't exist. We try to find the request the rest of it. In load data, you because like you can when you get the period from start to end longer than 40 days, the return data are going to be weekly instead of daily. So we have to get the like a chunk of 30 days at a time, and within that period, the day with the most trending is going to get the earned as a value. And um, so if you get two period without any overlap, you both get like each gonna have like one row with 100, but there's no way you can normalize and make the correlation between two set of data. So what we do here is we get 30 days, and we get the last day plus another 29 day, and use that overlap day to normalize the two set and merge them together as in the function merge right here. The get current data is just guess the more current one, and in our case here we get 2 days worth of data, the last one, and today normalize it and add it to our record. And finally the close function, which is just save the data into database, which is our file CSV file. So for the finance API, it do the same thing. The file name is going to save is finance data CSV, and at first the API is going to pull in the historical data that we put inside. It also get data, which is try to get the maximum in historical, and call load data to get the rest of it. The function here, it do a lot of data cleaning. Like Yahoo Finance provide a bunch of like data, min max price, open price, like variation of data during the day. So we don't need all of that. We just need closing data. So we clean now, fill in the non-data, which normally caused by market close over the weekend or holiday. The get current function do the same thing as the Google Trend data, and just populate the new most current one to the original set of like for 2 days. And finally, the close function do the same thing. It save the data into the Google Trend no, finance data.csv. I designed this way because like there's no abstract class, because like even though the A2 API said the same function name, but almost every function you have to override it. So it doesn't make sense to create an abstract class. The next step is the model. So this is generic model for any other, like the next model to inherit. So this is the abstract class. So what you need to specify is the model name, which is the file the model is going to be saved to. So if the user have like a really nice model already, they can save it down for future use. The model class is the module come from the scikit-learn library. Sorry, and you can populate extra arguments, which the keyword you can find exactly on the Google Doc and on the scikit-learn documentation page. So to initialize the model object, you have to put in the Finance API object and Google Trend API object. The purpose of this design is you can have multiple model using the same APIs. The benefit of that is you save a lot of memory. Second, you don't have to make duplicate calls. So if one model already make the API get more data, the next model can utilize that newly achieved data. Finally, is the race condition. Is when you have when you finish using it, the API save the data into the file, and if you have multiple API running, you can run into the problem of the first API being closed. You have more data, and the next one coming up will erase all of that data. We have to do this by ourselves because we don't have a database which maintain our integrity of the data set, duplication, indexing, or unique constraint, that kind of thing. So we have to do everything ourselves. So the first with going to the next line is the module going to try to find existing file that contain the model. If in previous session the user set up the model, so our we will load it up. Otherwise, it's just initiate new model object. The train function, you have start date and end date, which going to be from the GUI, and it just asks the two API return the training data, and we merge two set of data from two API together, remove all the missing value because we don't really have an algorithm for the missing value in this instance, and create like the input set and the output set and start the training process. The predict function is just that when you get a model fitted already, you can input different values for input and get a prediction out of it. This can be used for the function get current, you get the current prediction, and all you user can have the choice of input their own input for like hedging purposes and get the prediction of Bitcoin based on those input. The score function is for the user to evaluate how good their model is. So in the normal machine learning, you divided your big set of data into 20 and 80 for testing and training. However, it doesn't work here because the high volatility of Bitcoin. So even if you train the model and test in the same period of time and you get a good result, it's unlikely for you to get the good result on the most current data. So our score function is try to evaluate the current model on the last 30 days worth of data, like today minus 30 days, and it evaluated by taking the sum of the square of the difference between the predicted price and the actual price, and return the user a float number. So the smaller the value, the better your model is. And finally, the save function, which is you can just set all of your function arguments into a nice file in the model folder for future use. So you can see right here, because we get good abstract class, every model is very easy to code up, and you need like font line maximum, and you can just like play with the extract argument to tweak it up, so user got the best experience out of it. Right now I already coded up the lasso regression, linear regression, ridge regression, SVM regression, Bayesian ridge regression. So 5 model, but to create like 5 more models without tweaking around, it's like pretty easy. Finally is the GUI, the main part running every component I explained before. So first of all, it just create a Windows and name it BTC prediction model. So before going further, I can explain the 2 utility function I have right here. One is for passing float. So you have a float number that is in human format, normally created by the clean function right here. So the clean function convert the Python float to a string like string formatted float with commas in it for easier use. So for example, 1000 going to be 1000, and much easier to use. This is come in really handy for the trading volume of Bitcoin, going to like millions of coins a day, or the S&P 500 values. So if you just have a long float number, it's very difficult for user. They have to like separate 1000 to million by themselves. So this is the 2 utilities for. So in the GUI, we continue. So we create 2 API object, one for each type, passing to our 4 models right here, and then we create the boxes. And you can see the GUI right here. There's not object-oriented programming because we only have 1 GUI. So this is the 4 boxes, and then the refresh button for the to get the most current price. And next up is just the score and the prediction for each model, as the same thing provided by the generic model.py. And here you have the right here you have the check boxes, so you can choose like which model you want to retrain on, and you can select the start date and the end date of each of you want to train on. And there's other function, for example, like how button closing. I will explain it in the another video for the GUI demonstration.